Today we're going to learn how to divide polynomials, and some of this you already know. Like I bet you know how to divide, well I call these, well I should change the color, how to divide a polynomial divided by a monomial. I call these share the love problems. Share the love. Share the love problems. And what I mean by share the love is that this 3a has to be divisible or divide into each term, because really this means 18, I want it right, 18a cubed over 3a plus 30a squared over 3a. (30a squared over 3a). Doesn't want to write it. 3a. a squared. So then we would share the love and we would divide each of those. So here this would turn into 6a squared plus 10a. 6a squared plus 10a. Doesn't want to write there. The next one, and you don't even have to write out those mini fractions, right? You can just divide them in your head, right? So you could take this here and divide it into both of these. Why is that not writing? There we go. So this would be what? 6n cubed over m minus 10. And that's it. And then this is a longer share the love question here. So this would be 4pt, right? Minus 7qr cubed minus 3p. Okay, so those should be easy doing them in your head. Now we review dividing polynomials the long way, or dividing numbers the long way. Do you remember how you learned back in elementary school to divide 12 into 493? Didn't you first divide 12 into 49 4 times, and then what did you do? Right, multiply. 4 times 12 is 48. And then what did you do with the 48? Yes, you subtracted it. 48, and then you subtract. Right, 48, and then we subtract. (48) subtract. There we go. So 48 minus 48, pretend that that's an a, there we go, is 13. And then we bring down the 3, right? So divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. And then we do it again, right? 12 goes into 13 one time. Come on. Doesn't want to write here. Sorry. 1. I'm doing it with my finger, and then that's not really as easy to do. And then I would multiply 1 times 12 is 12, subtract, and then I get that remainder, but I usually would write my remainder over the divisor. So we're going to do the same process, but with polynomials. Let's see if it'll let me write here. X minus 3 goes into x squared plus 3x, x times. When I multiply, I get x squared minus 3x. Now when I subtract, I'm going to change both signs. And I like doing that in a different color. Now I can add 3x and 3x is 6x and bring down the negative 18. Then I ask myself, how many times does x go into 6x? It goes in 3 times. Multiply. Sorry, it goes in 6 times. My bad. It goes in 6 times. Multiply, so I get 6x minus 18. and then change the signs, and then luckily that one goes in evenly. So what that means that goes in evenly, that means that we could have factored this into x minus 3 times x plus 6. I mean, that's really what the problem is asking us to do. Divide into here, and what's the remaining factor? It doesn't always go in evenly, just like dividing 12 into 493 didn't go in evenly. So here, if I divide m plus 2 into m squared, I ask myself, how many times does m go into m squared, which is m times? Multiply, so that gives me m squared plus 2m, m squared plus 2m plus 2m. Then I'm going to subtract by changing the signs. These will cross out, negative 5m, bring down the negative 7, negative 5m minus 7, and do it again. M goes into negative 5m, negative 5 times. If I multiply, I get negative 5m minus 10, negative 5m minus 10. Subtract, so I change the signs. And then negative 7 plus 10 is 3. That's my remainder, 3. And I'm going to write my remainder over the divisor. So the remainder goes over m plus 2. And that's my answer there. Number 5 is a little bit different. It's written different, so I'm going to rewrite it. P minus 1. P minus 1 divides into p cubed, and then I'm going to write some placeholders here. P cubed plus 0p squared plus 0p plus or minus 6. And those are like placeholders, okay? It's just like if you were to subtract like 4 minus 2.6, that you might add a 4.0 in there in order to subtract, right? You might add that in so that you could do your borrowing. It's the same thing. We're adding these in as placeholders. They're not changing the problem. So now I'm going to ask, how many times does p go into p cubed? That goes in p squared times. I'm just going to get rid of this for a second so I can write my answer. So it's going to go in p squared times. When I multiply that, I get p cubed minus p squared. So now you can see why we wanted those lined up. I change the signs, so I get p squared plus 0p. P goes into p squared, p times. If I multiply there, I get p squared minus p. Change the signs. 0p and 1p is p minus 6. This is going to go in one time. P minus 1. Change the signs, and I get a remainder of negative 5 over p minus 1. Phew, right? That's a lot. Last one. Last one here has a 3x minus 2 to the negative 1 power. The negative 1 power, you remember, means it belongs in the denominator. So this is like this divided by 3x minus 2. This divided by 3x minus 2. Come on. So that's the same thing as basically saying that 3x minus 2 is the divisor. 9x squared plus 9x minus 10. If I say how many times does 3x go into 9x squared, it goes in 3x times. I'm going to multiply 9x squared minus 6x. Sorry, I had to use my finger here. Change the signs. That adds up to 15x, and I bring down the 10. 3x goes into 15x 5 times, and now I'm lucky. 15x minus 10. So what does that mean? When I change the signs, no remainder, that's my answer. So this can take a little bit getting used to because I know there's a lot of steps. These are the steps, same steps you learned in elementary school. I suggest when you do the subtract step that you do it in a different color so you see when you have changed signs. Dividing polynomials.